Hello and welcome to your lesson on domain and range of functions. So today's objective is that scholars will identify the domain and the range of functions presented in different ways. Again, this is also your note paper, so please make sure that you go ahead and put your name and section on it and have this as your notes. So first we have some quick vocabulary, and we've gone over this vocabulary before in your lesson on what functions are. But let's talk about this again. So the domain is the set of all of our input values of a relation. It's also known as the independent variable or the x variable. On a graph, it's always shown on the horizontal axis. Okay, so then we have our range. The range is the set of all output values of a function or relation. It's also known as our dependent variable or our y value. It's always shown on the vertical axis of our graph. Okay, so remember, domain, input, x value are all used pretty much interchangeably. Same thing with range, output, dependent variable, y value, all of that's used interchangeably as well. Okay, so let's talk about how we find the domain and the range. So remember, domain is our input. So we're simply going to list the values and we list them in numerical order. So our domain here, we use a little curly bracket, is 2, 3, 4. Our output, again, is our range. So our range is going to be these values, again, in numerical order. 20, 30, 40. Again, we're going to put it into the little curly brackets. 20. Make sure you have commas in between the values. 30, 40. Not too hard. So this is with our mapping diagram. It's just we have our input mapped to our output. Okay? So now let's look at the domain and range of a set of ordered pairs. So here I have a set of ordered pairs. Remember that when we have a set of ordered pairs, they are always written x, comma, y, and domain is our x values. So in this case, our domain, again, we're going to put it in a little set of curly cues, is going to be 0, 3, -3, 2. And our range is going to be the set of our y values. Our range is going to be 2, 4, -2, and 4. Again. So we aren't going to list it twice, so we're actually going to not list that last range because it's the same number. We only list them once each. Okay, so when you have a repeated number, you're not going to list it twice. Okay, so let's come to what happens when I'm looking at it on a table. Again, input is our domain, and we're just going to list them. So in this case, my domain is -2, -1, 0, 1, and 2. And the output is our range. In this case, our range is 0, 1, 2, 3, 4. Okay, so very easy with the ordered pairs, the mapping diagrams, and the table. Well, let's come here. Now I have a graph. So let's remember our domain is our x values, which are always shown on our horizontal axis. So our x values are shown here. So I'm going to go from left to right, listing my x values. So my first x value is 1. My next x value is 2. My next x value is 3. My next x value is 4. Next x value is 5. My next x value is 6. So that is the range, or the domain there. Next, we're going to look at the range. So remember, that's our set of y values. Remember that y values are shown on our vertical axis. So I'm going to go from the lowest point to the top. So my range here is -1. And I have this one is at 0. This one is at a y value of 1. That one's at a y value of 2, y value of 3, and a y value of 6. Again, I just find my y values by going over to see where it hits at the y-axis. Same thing I did with my x values. Okay, now what if I have a graph that looks like this, where I've got a line? Again, my domain is all my x values. But I'm looking at this, and I notice that we have these arrows on either side. So it's continuing on forever and ever and ever. My domain, my x values, then it looks like it can be anything. So my domain here is going to be infinity. Any value of x will have a y value. Same thing with my y. Again, we're going vertically. We're going to go forever and ever also. So my range is also going to be infinity. When I have a line, especially any that is horizontal, that is not horizontal, I'm sorry, that is slanted in any way, has any slope other than 0, it's going to have a domain of infinity and a range of infinity. Okay, so what about when I have an equation? Well, remember, this is a linear equation. I can put in any value for x and get out an output for y. So if I put any value in for x, then my domain is infinity. And I'll get out any value. If I graph this, it has a slope of 3, so it would be something like this. So, and my range is also going to be infinity. So this one, again, will have an infinite range and infinite domain. Some other equations that we'll get to later will not have that, but in this case, a linear one will always have infinite domain and range. Well, now let's talk about this. Domain and range of a situation. So sometimes you're going to be given a situation to find the domain. So in this case, the temperature outside is a function of the time. So first I need to figure out what is my input and what is my output. So the thing that is my input is going to be the time here. That's the independent variable. It will be whatever time it is. Each time can only exist once. My output is going to be the temperature. So that's the first thing we need to do, is figure out what our possible inputs and outputs are. So if our input is time and our output is temperature. In this case, our domain would be any time, right? It can be any time, so it's going to be infinite. And the same thing with our range, our temperature. But we might have a limit. Let's say that your limit's going to be whatever the lowest temperature ever recorded on Earth would be the limit. So let's say like negative 100 degrees Fahrenheit. And then again to our maximum of, let's see, this minimum. So x is greater than, y is greater than that, which is greater than, let's say, 150 degrees Fahrenheit. So we have a range here. Okay? So in this case, we have a little bit of a range. So that's, in the real world, we do have some limits there. Okay, so go ahead and do your practice, and I will see you in class if you have any questions.